Hello, everyone. So we have a 2022 AMC 12 problem. So this was number 17. So this is a good identity problem. So let's get started. So we are given A is a real number such that the equation has more than one solution in the interval of 0 to pi. And the set of all A can be written in this form where those P, Q, R are real numbers, and then P is lesser than Q, and A is lesser than like R. And we want to find their sum. Okay, so it looks a bit challenging, especially for number 17 for some people. But since we have sine x, sine 2x, sine 3x, it looks like we can just use the angle, like double angle and maybe triple angle and stuff. But if you don't really know how to get those, maybe it's better to remind. So angle sum for sine, let's say sine A plus B, is equal to the sine of the first angle, which is A, times cosine of the second angle, plus cosine of this first angle and the sine of the second angle. As long as you know this, then the other two will be easier to get it. So if I want to replace A and B as x and x, so yeah, we'll get sine x plus x, which is, I'm going to write it as for now, equals, so I just replace A and B as x, so that will give us sine x times cosine x plus cosine x and then sine x. So as you see, the product sine x, cosine sine x, they are the same product. So we have two copies, and then this will be now the sine 2x is equal to 2 copies of sine x and cosine x. So if you already know this one, so the previous, like the step that I just took right now is just a reminder. So I'm gonna highlight this, this is important. And now if you wanna find the sine 3x, which we can use a similar approach. So I will go ahead and write sine 2x plus 1x, which is gonna be 3x, right? And if I just plug into the original identity we have right there, so that will be sine of the first angle, which is 2x, times cosine x, plus cosine of the first angle times sine of the second angle. So the left side is sine 3x, and the right side, so I have sine 2x and cosine x and stuff like that. Maybe we can play with those a bit. So we have sine 2x. If I expand the sine 2x, which is 2 times sine x times cosine x, so I will write 2 times sine x times cosine x. But there is another cosine, so I'm going to leave it as it is. And plus, we have like cosine 2x. If you do remember the cosine 2x, it's good to kind of remember now. There are a couple of ways to write the cosine 2x, so I'm going to write it here. So cosine 2x is equal to cosine square of x minus sine square of x, or 2 times cosine square x minus 1. They are easily can be like derived from each other, or there is another way that we have 1 minus 2 times sine square x. Again, these three can be derived from just the angle sum for cosine, so you can just make them equal and then get these. So, but the question is, like, which one should we use, like for this cosine 2x, right? So we have sine 3x is equal to something. So on the left side, we have sine cosine, which is cosine squared x. So maybe we should write this guy in terms of cosine, so which is equal to 2 cosine squared minus 1. So if I write that, so 2 cosine squared x minus 1 times sine x. Okay, so let's clean this a bit. So this one is cosine squared x, right? So I can just, like, maybe I can write cosine squared, and there's a sine x times this parenthesis, sine x times this cosine squared x. So I will pull the sine x as a common factor. So if I do that, so you will get 2 times cosine squared x, 2 cosine squared x plus there is like 2 cosine squared minus 1. So 2 cosine squared x minus 1. Okay, so if I rewrite these a bit better way, so sine 2x times 4 cosine squared x minus 1. Okay, so this is a sine 3x. Again, all of these that what I did so far is something you maybe already know, so which is you can skip all of these steps. But if you don't really know all of these so far, I would say take a look at those and redo this on your own, because these are the really common identities we should remember. And this is the triple angle for sine. So this is one way that we can write it. But on the left side, so let's go back to our actual problem. So on the left side, we have a, and then sine x plus sine 2x, which is this identity. So 2 times sine x times cosine x. On the right side, we have sine 3x, which looks like this. Since we have sine x and sine x right here, there is a sine x right here. So maybe I can, I don't know, like pull those as a common factor, so which might be useful. So let me write that. So the sine x times 4 cosine squared x minus 1. So I may change this into sine, and then I need to deal with that as well, which is not easier because this is not square of cosine, which is why I don't want to do that. But at the same time, this is square of binomial, so we have something square and minus into square. So I hope I will get something similar to this one on the left side. If I pull the sine x from the left side, so you will get a times sine x times, if I pull this sine, so you will get 1 plus 2 times cosine x, which is good. And I'm going to pull these to the left, because if you are wondering, can I simply cancel sine x's? We cannot, because we don't know if they are equal to 0. Maybe we can, because we are told actually we cannot, because it's in between 0 to pi, so which means we can actually divide by 0. I mean, divide by something, because sine x is not 0 in between those, which is safer, but I'm going to leave it for now. And then minus sine x times this guy, so that can be written as 2 cosine x minus 1 times 2 cosine x plus 1. So again, if you don't really see that, so this is just the difference of square of this part, and then I just subtract the product from both sides to get this equal to 0. So now we have the sum terms are that is common, so sine x is common, 1 plus 2 cosine x is also common. So if I pull those as a common factor, so sine x times 1 plus cosine, 1 plus 2 cosine x. So when I pull this as a common factor, so I will have a left over, minus, I pull this guy, and then I pull the positive version, so the negative version just there still. So minus 2 cosine x minus 1 is equal to 0. So if the product of stuff is equal to 0, then each can be 0. So sine x is equal to 0, or this product will be 0. 1 plus 2 cosine x should be 0, or this has to be 0. You know, for this has to be 0, a has to be 2 cosine x minus 1. Okay, so sine x like cannot be 0, because we already know the x is in between, right? X is in between 0 to pi, so sine x is not going to be 0 in those, because it's just larger than 0 all the way to the 1. So in order for this to be 0, so if I find the cosine alone, so you will get negative 1 over 2. So there is one value that could be the case, which is the negative 1 over 2 for the cosine. So we can have something in that range. Okay, and then for this guy, if I want to find the cosine in this equation, so you will get cosine x is equal to, if I add 1 to both sides, you get a plus 1, and then divided by 2 to get cosine. So we already have one value from here, one value from here. So since we are told the equation has more than one solution, so if that's the case, then the x, like cosine x equals to this number, so cosine x equals to this number, which means -1/2 and a plus 1/2 should be two different numbers. Otherwise, we have only one solution, so which we don't want. So then, in that case, we do know this cosine value could be anything in between 1 to -1 because that's the cosine function in the region. So let's go ahead and do that. So -1 all the way to the a plus 1/2, the +1. If you multiply by 2 to -2 and +2, subtract 1, so you will get -3a, and then there will be 1. So that is the a. For the second one, we know this guy, -1/2, is not equal to this number. So let's make that sure. So -1/2 is not a plus 1/2. So if you multiply by 2 and subtract 1, so you will get a equals -2. So meaning that a shouldn't be -2. Okay, so then we could have a as anything larger than -3, but not -2, all the way to the +1. So which means our solution should be like this: -3 all the way to the -2, and union -2 all the way to the +1. So that is my solution set in this form. So PQ is these numbers, -3 and -2, and then R is 1, so that's -5 plus 1, that is -4. So I hope that was clear. So it was a bit complicated. So the red part, the proving the identity for triple angle and the double angle right here, and even with the cosine double angle, is just a reminder. And if you don't know how to get them, please try those on your own because those are really common. So you want to skip those first like steps, okay? So I'll see you in the next video.